Today we will see program status word PSW resistor of 8051. Okay. Now program status word P stands for program, S stands for status, or W stands for word. Now when we say word, we know that 8 bits are called as word. 8 bits together we call it as a word in 8051. Now status of what? Program. So definitely this resistor is responsible for telling the status of program execution. This PSW will tell you the status of arithmetic operations. Now if you want to know if you have written a program for addition, say for example, after the addition is performed, you can check this PSW register to find out various things. So let us see the format of PSW register. Now PSW is one of the SFRs. Now what is SFR? Spatial function resistor. So this is spatial function resistor. Now there are functions assigned to each bit. Now it's an 8-bit resistor. You can see this is a D0. Then this is D1, D2, D3, D4, D5, D6 or D7. Out of which 2 bits are for the user. Now there are user defined bits. Now this bit is user defined bit and this bit is user defined bit. So these 2 bits are user defined. User can use it at his or her disposal. Other than these 2, 6 bits are there. This is P, D0 bit. P stands for parity bit. Here you can see P stands for parity. Then OV stands for overflow flag. Now each bit is also called as flag, and this PSW is also known as flag resistor. Now each bit is also called as flag. Again, the flags are also used for indication. It indicates something. Now what does it indicate? We will see. Now out of these 6 flags, this parity, the D0 is parity, then D1 is not used, D2 is overflow flag, then other 2, next 2 flags, Rs0, Rs1 are resistor select flags. You can see resistor bank selector bit 0, resistor bank selector bit 1. Now these 2 flags are actually not giving you any status as such, but user is actually responsible to program these 2 bits in order to select appropriate resistor bank. Now next is F0, which is again is user defined for general purpose. Then AC. AC is for it's called as auxiliary carry flag, and CY is of course the carry flag. So D7 bit is CY. So in this slide, let us first see the role of Rn0 and Rs1. Now as you know, there are 4 resistor banks in 8051. Bank 0 address is from 00 to 07. Bank 1 address is from 08 to 0F. Bank 2 is the address, and bank 3 is the address. So there are 4 banks. Now out of which this bank 0 is default. Out of which bank 0 is default bank. That means if you do not select it by programming these 2 bits, then obviously by default this particular bank is selected. Now if you want to select bank 1, then you will have to program these 2 bits. As we see, we have to program these 2 bits accordingly. That is, you have to keep RS1 0 and RS0 1 so that a bank gets selected. Now how do we program these 2 bits? Now this PSW resistor is bit addressable. That means you can access each bit of these resistors individually. So what you can use instruction set B PSW dot 0 1 2 3 PSW point 3 to access this particular bit. And similarly, you can say set B PSW dot 4 fourth number bit, 0 1 2 3 4 RS1, so that you can set both the bits to 1 1. That means you are selecting register bank number 3. Now this is how you can program set this bit. And for that making this any particular bit 0, we use this clear instruction. This is how we can select any particular bit. Now let us look at the functions of other resistors. Now parity. Now when does parity bit is set? Now this parity bit can have 2 values, that is 1 or 0 in 8051. Now parity is decided based on the number of ones in the accumulator. If number of ones are odd, then the parity bit is set to 1, and if number of ones are even, then parity bit is set to 0 in case of 8051. Now let us see what is the use of parity bit. Parity bit is used for error correction. Whenever you want to send any data from one microcontroller to another microcontroller, you can use this parity bit for error correction. Now let us look at the carry, when carry bit is set to 1. Now whenever you are doing any addition, if there is a carry generated from the last, that is MSB, for example, this is your data 10011000 plus 10000001. If this is the addition that you are doing, 8-bit addition, then as you can see here in the left, this is MSB, so this is a D7, right? So 1 plus 1 is 0 and plus carry is generated 1. So this is your carry which is generated. So when this happens during the calculation arithmetic operation, carry bit is set. Now let us look at this auxiliary carry. Now say for example, if addition of 2 numbers, if these are the 2 numbers which are being added. Now you just pay attention to this D3 bit. This is D3, D0, 1, 2 and 3, and this is D4 bit. Now what happens here? 1 plus 1 is 0 and carry is 1. So carry is transferred from D3 to D4. This is called as one nibble, this is another nibble. Nibble is nothing but 4 bits. So the carry is transferred from D3 to D4. So this is where when this happens, this carry bit, auxiliary carry bit is set. Okay. Now let us look at the overflow flag. Now there are 2 types of operations: signed arithmetic and unsigned arithmetic. What just now, this is unsigned. Now in case of signed arithmetic, okay, this particular overflow flag comes handy. Overflow flag. Now overflow flags is set to 1 when overflow occurs. That means when uh, similar to that carry. Now how carry gets generated, carry flag gets set in unsigned arithmetic. Similarly, overflow flag gets set when there is a overflow. When you have carry generated from this allocated 7 bits, in that case we can say that the overflow has occurred. So that is for signed arithmetic. And then we have already explained what is the role of Rs1 and Rs0. So to sum up again, parity bit is set when number of ones in the accumulator are odd. Overflow flag is used in signed arithmetic when there is the overflow. Now if we don't pay attention to the overflow, there could be error in the calculation. So this is important while carrying out signed arithmetic. These two flags Rs0 and Rs1 collectively programmed for selecting a particular resistor bank. F0 is user defined again. Here also this also is user defined. This is auxiliary carry when the carry is generated from D3 to D4, and carry when the last bit is set when there is a carry generated from addition of D7 bits. So this was about PSW resistor of 8051. Thank you so much.